start off screen. Now I'm on screen. There were some questions or some requests for some more examples of multivariable domain and range. So let's take a look here. Here's a function, f of x, y is the square root of y minus x squared over x squared minus 4. So there's two things we have to deal with here. The first is that, well, not the first, one of the things is that we know that x squared minus 4 can't equal 0. So x can't equal plus or minus 2. And then we also have that y minus x squared is greater than or equal to 0, or y is greater than or equal to x squared. So if I try and graph this, here's what's going to end up happening. I'm going to have y greater than or equal to x squared, so I want to draw my domain in red. So here's y equal to x squared. If I want y to be greater than or equal to x squared, I should have everything above it, but I can also test the point, right? If I test the point like 0, 1, if x is 0 and y is 1, 1 is bigger than, well, 1 is bigger than or equal to 0 squared. Check. So that's there to all of this, except x can't be plus or minus 2. So over here at, say, 1, 2, and negative 1, negative 2, we don't get any of this. It's kind of a weird looking domain, I gotta say. Sorry, my parabola is not very symmetric here. Apologies, that's 1, 2. So, and then I've got kind of smashed up in here into my function here. My domain looks like all of this, everything above the parabola y equals x squared, except for the vertical lines x equal to 2 and x equal to negative 2. Kind of weird. Okay, the range is a little bit funky. Now, here's my experience with range. If you've got a function that looks like you could probably hit every real number value, it probably does. There's nothing here that's really going to keep us from doing it, but if we want to convince ourselves, here's what we can do. So I'm going to say, well, so I kind of want to make the denominator easy to kind of ignore, for lack of a better word. And I want this to be able to have, there we go. So to make the denominator easier to ignore, I'm going to try and set it to be 1. So like, what if I said x was equal to the square root of 5? Which is totally allowed, right? It's in the domain. Then the square root of 5 squared is 5. 5 minus 4 is 1. So my function, f of square root of 5 comma y, looks like the square root of y minus square root of 5 squared is 5 over square root of 5 squared is 5, which is just the square root of y minus 5. And now I know that the square root of y minus 5 can be any positive value because y can be any number bigger than or equal to 5. Right? So if y is 5, I get 0. If y is 6, I get 1. If y is 7, I get square root of 2. So every larger and larger y value gives me all the positive z values, or function values. So here we see from this that f of x comma y can be all values greater than or equal to 0. But we can also get the negative ones. And we can do that by setting x equal to the square root of 3. Basically, again, I'm trying to make the denominator plus or minus 1, kind of. And I'm pretty sure the numerator can be all the positive values. So if x is equal to the square root of 3, then this f of square root of 3 comma y is equal to the square root of y minus 3, right? Again, because x is going to be root 3, x squared is 3, all over 3 minus 4, which is negative 1. Divided by negative 1 just means you're changing the sign. So this is equal to the negative square root of y minus 3. And this is going to get us all the negative values, because again, if y is 3 or 4 or 5 or 6 or whatever, then the square root's a positive thing, but you get the negative of that, you get all the possible ones. So here we get all negative values. So here the range of this function is everything. Right, there's nothing that the function values can't be. Let's look at another example. This one's a little more normal. The natural log of e squared minus x to the fourth minus y to the fourth. So to find the domain, we're going to set the insides of a logarithm to be strictly greater than 0. Then I'm going to bring my x to the fourth, y to the fourth to one side. And I might have made a, we'll see here. Let's get e squared is bigger than x to the fourth plus y to the fourth. And fortunately, x to the fourth plus y to the fourth is not a circle, right? It's not x squared plus y squared. So this is just kind of a shape. Yeah, I made a, let's just change it. Let's just make it x squared, y squared like it normally is. Then it's easier to draw the shape. Let's just say it's that. Sorry about that. So then we see that the domain here, I was really thinking more about the range in this problem. So the domain, well, x squared plus y squared equal to e squared is a circle. Center is at the origin. The radius is the square root of e squared, which is just e. So here's what my domain looks like. So here's like e right there. I'm trying to draw a circle. I'm drawing it dashed because I'm not going to want to include the border because it's a strictly less than, right? This is x squared plus y squared is less than e squared. So here's my radius of e. And I want everything on the inside because if I plug in 0, 0, 0 squared plus 0 squared is 0, which is less than e squared. I want 0, so I want everything inside, but not including the boundary of the circle. For the range, well, for the range, we have a couple things going on. There's a number of ways to think about finding the range. Here, I'm just thinking, well, how big can this be and how small can this be? We know that e squared minus y squared minus x squared minus y squared has to be bigger than 0, right? We just said that. I also know that because this is really minus x squared plus y squared, and x squared plus y squared is always greater than or equal to 0, I know this is always going to be strictly less than or equal to e squared. We could have started further back. We could have been like, oh yeah, x squared plus y squared is bigger than or equal to 0, and then done like negative 0 bigger than or equal to negative x squared plus y squared, and then did e minus 0 bigger than or equal to e minus x squared plus y. That seems like a big old pain to get something that's kind of easy to see. So then we can say, well, so if the stuff inside is bigger than 0, but it can get really close to 0, we know that the natural log function goes down to, right, if you've got z equal to the natural log of some stuff, where the z-axis is like here and the stuff axis is over here, right? If the stuff gets really, really close to 0, which it can, then the z function values are going to go down to negative infinity. But the stuff is being stopped over here at e squared, right? We can't go past that, right? There's no way to make this expression, sorry about the plane outside, there's no way to make this expression larger than e squared. So we get stopped right there, and natural log of e squared is 2. Meaning our values go as low as negative infinity. I mean, we don't actually get to negative infinity. We're unbounded below, and as high as 2, inclusive. And that's it. Hope that helps.